welcome to section 4 of chapter 2 of geometry. Our topic today is deductive reasoning. Our objective is to use the law of detachment and the law of syllogism. So here we've got a problem. You're going to use a coupon to buy 3 different pairs of jeans. So it says buy 2 pairs of jeans, get a third free. So you narrowed it down to 4 pairs of jeans. One's $24.99, $39.99, $40.99, and $50. But you want to spend as little money as possible. And so you got to decide, what is the average amount per pair of jeans that you will pay? Explain. Now, if you notice on the coupon, there's something really important that it says. It says free jeans must be of equal or lesser value. And you're trying to spend as little as possible. And so if you're trying to spend as little as possible, you got to eliminate one of these 4 pairs of jeans. And so which one are you going to eliminate to keep your total as little as possible? And I would say you're going to eliminate the most costly pair of jeans. So if you eliminate that $50 of jeans, and you look at what you have now, free jeans must be of equal or lesser value. So of these 3 pairs of jeans we're talking about now, the free jeans must be of equal or lesser value. And so that means that of these 3 pairs of jeans we're now left with, the most expensive pair of jeans you have to pay for. And so we know we're paying for the $40.99. But then if we're thinking about the next 2, the free jeans must be of equal or lesser value. Well, the $30.99 is of lesser value to the $40.99, but it's not of lesser value to the $24.99. But they didn't specify that it has to be of equal or lesser value to both. They just said it has to be of equal or lesser value. And so I would say that your $39.99 pair is the pair you're going to be getting free. You're going to be paying for this $24.99 pair. And so if you add those two together, $24.99 plus $40.99, you got $65.98 for 3 pairs of jeans. So the average you're going to be paying is $21.99 for your pairs of jeans, which is a pretty good deal if you ask me. Now, unless you really argued that, they're probably going to give you the $24.99 pair of jeans free. And if they do that, you take your $49.99 plus your $39.99, you get $80.98. You divide that by 3, and you're probably going to end up paying $26.99 for your jeans. However, you could put up a big fight with a manager and get that $21.99 per pair of jeans if you really wanted to. And so this is deductive reasoning. And deductive reasoning is the process of reasoning logically from given statements or facts to a conclusion. And so given true statements, you can use deductive reasoning to make a valid or true conclusion. And so we've got a few different properties that we're going to talk about today. And the first one is the law of detachment. And so the law of detachment says if the hypothesis of a true conditional is true, then the conclusion must also be true. So it says if P implies Q is true and P is true, then Q must also be true. And so here's a statement that we have. It says if I have a calendar, then I can strain my spaghetti. And so we know that this statement is true. We also know that I have a calendar, which is true. So what conclusion can be reached from that? Well, I can then strain my spaghetti. And that is true then as well. And so here we've got a statement. It says, here's your given. If a student gets an A on a final exam, then the student will pass the course. Okay? And so this statement is true. All right? If the student has an A on a final exam, then the student will pass the course. So now we have Felicia, and Felicia got an A on her history exam, and this statement is true. So what can we then conclude from that? Well, we then can conclude that Felicia will pass the course. Felicia will pass the course. We conclude all that from just those 2 statements up there. And so here we have another one. It says, if a ray divides an angle into 2 congruent angles, then the ray is an angle bisector. So you have the ray RS divides angle ARB so that angle ARS is congruent to angle SRB. What can we then say about ray RS? Well, RS is an angle bisector. I'm going to call that ray RS since I can't notate that. And ray RS is an angle bisector because it divides an angle into 2 congruent angles. And so we use the law of detachment in order to conclude that. So here we've got another one that says, given if two angles are adjacent, then they share a common vertex. Angle 1 and angle 2 share a common vertex. And so the thing we need to be careful about in this one is that the statement says that if two angles are adjacent, then they share a common vertex. That's the statement we're given, right? And so we're given if two angles are adjacent. That's true. That needs to be true in order for us to be able to do the law of detachment. However, in our statement down below, they're saying angle 1 and 2 share a common vertex. That's the cue. That's not. That's our conclusion, not our hypothesis. So we cannot say that angle 1 and 2 are adjacent. If it said that angle 1, if our statement here was that angle 1 and angle 2 are adjacent, then we could say they share a common vertex. But just because they share a common vertex does not mean that they are adjacent. For example, here we have two intersecting lines. Here's angle 1 and angle 2. They share a common vertex, however, they are not adjacent to one another. So what I'd like you to do now is do this got it question. Pause the video, answer these two questions. And so here's what I can conclude from the statements. Here's my first one for A. If there's lightning, then it's not safe to be out in the open. Maria sees lightning, so that hypothesis is true, which means that it is not safe for Maria to be out in the open on the soccer field. In B, it says if a figure is a square, then its sides of equal length. Well, figure ABC has sides of equal length. We can't conclude anything from that because it's referring to the conclusion, not our hypothesis. It needs to say something about figure being a square in order for us to use the law of detachment. And so some stuff we need to know is that the law is another law. It's the law of syllogism, and it allows us to link two conditional statements by using the law of detachment twice. And so the law of syllogism allows you to state a conclusion from two true conditional statements when the conclusion of one statement is the hypothesis of the other statement. So let me show you how that's linked. Here's the law of syllogism. What it says is that if P implies Q is true, and Q implies R is true, then P implies R. So let's put that in in an example over here. It says, if it is July, then you are on summer vacation. Okay. If you are on summer vacation, then you work at a smoothie shop. And if both those are true, then you can say, if it is July, you're working at a smoothie shop. And so that's how the law of syllogism works. You use the law of detachment in both of these, law of detachment twice to get here. So here we have two statements. It says, if you wear banana peels as earrings, then you are crazy. If you are crazy, so that links up back to that conclusion. If you are crazy, then you stick jelly beans up your nose. So if you're going to wear banana peels as earrings, if you're doing this, what can I conclude about you? Well, using the law of syllogism, I can then conclude that you stick jelly beans up your nose. That's the conclusion I can then reach. So let's use the law of syllogism again. It says, what can you conclude from the given information? It says, if a figure is a square, then the figure is a rectangle. If a figure is a rectangle, then the figure has four sides. The important part here is that we have this Q here, and we have it again. So the conclusion is then restated as the hypothesis. And so then what we can conclude is that if a figure is a square, then the figure has four sides because of those connections through. So if you look at the next one, it says, if you do gymnastics, then you are flexible. So here's our conclusion. We would need to start the next statement with that conclusion. It says, if you do ballet, then you are flexible. Because right here, it did not say anything about being flexible, we cannot conclude anything from this given information. So we can't do anything more from that. All right. So what I'd like you to do now is here at the top of the page here, we have a got it problem. Pause the video here, try to complete these two problems. All right, if you take a look, conclusion then became my hypothesis in that first one. If a whole number ends in 0, then it is divisible by 10. If a whole number is divisible by 10, then it is divisible by 5. So I can say if a whole number ends in 0, then it is divisible by 5. However, in the next statement, my conclusion did not become my hypothesis in the second statement, so I cannot say anything about that. So using the law of syllogism and the law of detachment, we can make conclusions about different things. And so here I have a problem. We decide what we conclude. It says, if you live in Accra, so Accra is this little city over here, then you live in Ghana. So, okay, then you're going to live in Ghana. If you live in Ghana, so Ghana is this country right here, then you live in Africa. And what they tell us then is that Isa lives in Accra. And so if we think back to that, okay, if you live in Accra, then you live in Ghana. So we can say that Isa lives in Ghana. And if you live in Ghana, then you live in Africa. So the final statement we can get from this is that Isa lives in Africa. And we can make that through the law of syllogism and detachment. Alright, so what I'd like you to do now, pause the video, see if you can answer 3A and 3B on your. So through the law of syllogism, I was first able to come up with this statement. If a river is more than 4,000 miles long, it is the longest river in the world. And then through that, I was able to decide that the Nile, using the law of detachment, that the Nile is the longest river in the world. And so this 3B question, it stumped me. And so I was trying to think this through. It says, doesn't matter whether you use the law of syllogism or the law of detachment first. And so if we think about this, we kind of have to use the law of detachment to start off to state that the Amazon is less than 4,000 miles, and that's something we can always verify. And if we verify that, then I would say we could use the law of detachment, and then we can say that then we can use the law of syllogism to determine that the Nile is 4,000. That if a river is more than 4,000 miles long, it's the longest river in the world. And then we use our law of detachment just to say that the Nile is the longest river in the world. So I suppose I would say we, in the end, probably need to use the law of syllogism before we use the law of detachment.